Have you ever wondered if you could teleport from one place to another instantaneously? Now, hold that thought. Let's take a dive, not into the realm of science fiction, but into the fascinating world of quantum mechanics, where such a phenomenon is not just a figment of imagination, but a reality. This reality is what we call a quantum leap. Imagine an electron, a tiny subatomic particle with a negative charge. It's constantly in motion within an atom, but it doesn't just move randomly. It resides in specific energy levels or shells. Now, this electron can't just take a casual stroll from one energy level to another. Instead, it performs a move that would leave any magician in awe. It leaps. This leap, or the quantum leap as it's known, is an abrupt transition of the electron from one energy level to another, without appearing in between. One moment it's here, and the next, it's there. No walking, no running, no flying, just a sudden instantaneous leap. It's as if the electron teleports. This concept, as mind-boggling as it may seem, is a cornerstone of quantum mechanics, a field of physics that deals with the weird and wonderful world of the very small. Quantum leaps are fundamental to our understanding of the universe, from the structure of atoms to the creation of light. You see, when an electron makes a quantum leap from a higher energy level to a lower one, it emits energy in the form of light. This is why when you heat up a gas, it glows. The heat provides energy to the electrons, causing them to leap to higher energy levels. When they leap back down, they release this energy as light. So, the next time you switch on a light, remember you're witnessing millions of quantum leaps happening right before your eyes. So, while we can't teleport ourselves just yet, electrons seem to have mastered this trick. What if we told you that a quantum leap is not a leap at all? Yes, you heard that right. The term quantum leap often conjures up images of particles vaulting over vast distances, but that's not quite the case. In reality, it's a bit more nuanced and far more fascinating. You see, when we talk about a quantum leap, we're not talking about a physical leap across space. Instead, we're referring to an instantaneous and rather mysterious transition that quantum particles make from one energy state to another. It's more like flipping a switch than embarking on a grand leap. To understand this, let's think about an electron in an atom. The electron doesn't just roam around freely. Instead, it exists in specific energy levels or states. When it absorbs energy, say from a photon, it can jump to a higher energy state. But here's the kicker. The electron doesn't traverse the space between these states. It simply disappears from one state and reappears in the other, almost as if by magic. This phenomenon is a bit like teleportation, except it doesn't involve any physical movement. The electron doesn't climb the energy ladder rung by rung. Instead, it simply quantum leaps from one rung to another, bypassing the space in between. So why do we call it a leap? Well, that's a bit of a historical quirk. The term quantum leap was first used by physicists to describe these abrupt transitions. Over time, the term entered the popular lexicon and started being used to denote a significant or revolutionary change. But in the quantum realm, it's not about dramatic leaps across space. It's about these sudden, unpredictable shifts from one energy state to another. So there you have it. The quantum leap is not a physical leap at all. It's a mysterious, instantaneous transition that defies our everyday understanding of how things should work. In the quantum world, it's all about state transitions, not leaps. Did you know that quantum leaps are instantaneous and unpredictable? Yes, you heard that correctly. Quantum leaps, in their mysterious and paradoxical nature, are both instantaneous and unpredictable. Let's dive into the instantaneous aspect first. Picture this. An electron is in one place, then suddenly, it is in another place. It's not that it traveled from point A to point B in a blink of an eye. No, it simply disappeared from the first place and reappeared in the other. It didn't spend any time in between. This is what we call an instantaneous quantum leap. It's as if the electron has mastered the art of teleportation, performing a magic trick that would leave even the most seasoned illusionist in awe. Now, on to the unpredictable part. This is where the Heisenberg uncertainty principle comes into play. This principle, named after the physicist Werner Heisenberg, states that it is impossible to know both the exact position and momentum of a particle at the same time. The more precisely one property is known, the less precisely the other can be known. This inherently makes the exact moment of a quantum leap unpredictable. Imagine trying to catch a falling leaf on a windy day. You know it's falling from the tree, but you can't predict exactly where and when it will land. That's what it's like trying to predict a quantum leap. The electron is there one moment, and then, in an unpredictable moment, it's somewhere else. So what does all of this mean? It means that quantum leaps, these essential components of quantum mechanics, are both instantaneous and unpredictable. They are like the ultimate magic trick happening in the blink of an eye and keeping you guessing. They push the boundaries of what we understand about the natural world, adding a dash of mystery to the science of the very small. Quantum leaps are like magic tricks. They happen in the blink of an eye and keep you guessing. Ever wondered how quantum leaps impact our daily lives? Well, the answer to that might surprise you, because the concept of a quantum leap isn't just confined to the realm of the tiny. It's played a crucial role in the development of many technologies we use every day, and promises to shape the future of technology in ways that we're just starting to understand. Let's start with lasers. They're everywhere, in your DVD players, supermarket scanners, even in the fiber optics that carry your internet data. Now, the operation of lasers rests on a fundamental quantum leap, the transition of electrons from a higher energy state to a lower one, releasing a photon in the process. Yes, those red beams are a direct product of quantum leaps. Then there are semiconductors. These are the backbone of our digital world, found in everything from your mobile phones to your laptops. And guess what? The entire operation of semiconductors is based on quantum leaps. The ability of an electron to jump from the valence band to the conduction band and vice versa is the magic behind your digital screens. And it doesn't stop there. Even the MRI machines at your local hospital owe their existence to quantum leaps. The way these machines generate images of the human body is by manipulating the spins of hydrogen atoms in water molecules, a process that is, at its core, a quantum leap. But the most exciting application of quantum leaps could still be yet to come. Quantum computers, the next frontier in computing, rely on the principles of quantum mechanics. Quantum leaps, with their ability to exist in multiple states at once, could revolutionize computing, making them exponentially faster and more powerful than any supercomputer today. So, you see, quantum leaps aren't just a fascinating scientific concept. They're the key to understanding and harnessing the power of the universe, both at its smallest scales and in our everyday lives. Quantum leaps might seem like a far-off concept, but they're at the heart of our modern technology. Despite all we know, the mystery of quantum leaps continues. Quantum physics, a realm of science that has been both fascinating and perplexing for scientists for over a century, still holds many secrets within its intricate web of theories, principles, and phenomena. One such enigma is the quantum leap. Recently, a groundbreaking experiment managed to capture a quantum leap in action for the first time. Clearly, this isn't a small feat. Imagine trying to photograph a hummingbird mid-flight, but the hummingbird is invisible, the size of a speck of dust, and it moves at the speed of light. That's a simplified version of what these scientists achieved. This monumental achievement, however, has only opened the door to more questions. One of the most baffling aspects of quantum leaps is their instantaneous nature. In the world as we know it, nothing happens instantly. Even light, the fastest thing in the universe, takes time to travel. So, how does a subatomic particle manage to leap from one energy state to another in no time at all? Moreover, we're still trying to crack the code of predicting these leaps. Quantum mechanics is inherently probabilistic, meaning we can only predict the likelihood of a quantum event, not when or how it will definitely occur. This unpredictability is a stark contrast to the deterministic nature of classical physics, where given the initial conditions, the outcome can be predicted accurately. The quantum leap, in essence, is a manifestation of the weirdness and wonder of the quantum world. It is a clear demonstration of the fundamental differences between the quantum and classical realms. It reminds us that at the most basic level, nature doesn't play by our rules. The quantum leap, a concept as fascinating as it is mysterious, and one that continues to challenge our understanding of the universe.